we know that if we've got pi in x, 1 minus pi in the risk-free, then the variance of our portfolio is going to be pi squared times the variance of x plus 1 minus pi squared times the variance of RF. And then we've got 2 pi, 1 minus pi covariance of x and RF. What's the variance of RF? Well, it's ERF minus ERF squared. But if RF is constant, what do we know about it relative to its mean? It's the same. So what's the variance of the risk-free? 0. So this term drops out. What's the covariance of the risk-free with stocks? Risk-free is fixed. The stocks move around. Do they co-vary? Vary together at all? No. Again, RF is always at its mean, and so this is equal to 0, and this term drops out. So we get that the standard deviation of the portfolio is just the square root of this, which is pi times the standard deviation of x. So now we get a particularly simple format, and we can work out what we get as we vary pi. So if we start out with pi being 0, we're at the risk-free. Then let's put pi equals a quarter. At pi equals a quarter, the expected return on the portfolio is going to be 0.25. We know means add, so we're going to multiply by 0.15. And then we've got 0.75 in the risk-free, so it's times 0.05. If you work that out, it's 0.075. If we use our standard deviation formula, it's pi sigma dx, which in this case is 0.25 times 2, which is 0.5. So in terms of where we are, we're at 0.5 for the standard deviation and 0.075 for the mean. At pi equals 0.5, our expected return is going to be what? Well, it's a half times 0.15 plus a half times 0.05. That's going to be 0.1 or 10%. The standard deviation of the portfolio is going to be 0.5 times 2, which is 1. So at 1, we're at 0.1. What am I chasing out? Let's do one more. At pi equals 0.75, the expected return on the portfolio is going to be 3/4 of the way in between, which is going to be 0.125. And here we're going to have that the standard deviation of the portfolio is going to be 0.75 times 2, which is 1.5. Again, it's 3/4 of the way in between. So if things move proportionally, what do we get? Straight line. So we get a straight line like this. Here you've got 100% in x. Here you've got 100% in the risk-free. As you increase the amount in x and lower the amount in risk-free, you trace out this straight line. Now, this is where the person was without the risk-free. Can they do better than that now? They can move to a higher indifference curve. Maybe something like that. So by mixing the risk-free with the risky stocks, they can make themselves better off. Can they do any better than that? Than this point here? Suppose I was to draw a point Y. If I mix the risk-free and Y, what am I going to trace out? Straight line again. Is the person better off from having that straight line available? Can they get on a higher indifference curve? Yeah. So they can do better. What's the best they can do? What's the very best they can do? Yeah.
You maximize as far up as you can go on those points in the middle straight when you just got it.
Right, so I'm going to go for which point in terms of this curve? I'm going to go for the tangency point. If I keep on going, what happens to the line? Comes back down, exactly. So this person is going to be best off by choosing M and the risk-free. They can get anywhere on that line by mixing RF and M in the right proportions. Does everybody see that? If you were more risk averse than this person, suppose you were down here, for example, what would be the difference? You'd still be holding M and the risk-free. What would be different? Okay, so go ahead, ask the question.
Like, is it true that you can go beyond M?
Yeah, we're going to do that in a minute. We'll come to that in a minute. Okay, so how do we get to here? What's the difference between this person who's near the risk-free versus this person? They have more in what? In RF, yeah. So we can be on this line, but then we have the next question which just came up, which is, well, what about above M? How do we do that? So let's just redraw the diagram so we can get some. We're going to come to that in a minute. Okay, so we'll use some logic here. Okay, so let's just figure out what's going on here. We've got mean standard deviation. We've got our tangency point like that. This is the risk-free. What is pi down here? If you got all your money in RF, we know that pi is 0. At M, what is pi? 1. So as we go up here, we know that pi is between 0 and 1. Now, pi is getting bigger. What happens as you get up here? What do you think pi is up here? So pi is greater than 1. What does that mean? Well, it means 1 minus pi is negative, which means that you're borrowing. So what you're doing in this portion is you're lending. You're lending to the government if you're buying government bonds. But here what you're doing is you're borrowing. So the way that you get up here is by borrowing. If you're down here, you're lending. Any questions on that? So why is it that when you borrow, your return goes up and your risk goes up? Well, first of all, yeah, Pedro.
Because you're leveraging your portfolio, so you're taking some money that you have to pay, and if something goes wrong, you still have to pay, so you have more risk.
Right, so let's do the return part first, then we'll do the risk. So why does your expected return go up when you borrow? What's the rate you borrow at? Risk-free. And what's the return that you get when you put it in the market? It's RM, which is above the risk-free. So you're borrowing at a low rate, investing at a high rate. Why is your risk going up? Well, it's as Pedro said, but let's look at an example. Let's suppose that you've got $100 wealth. If pi equals 0, how much have you got in the risk-free and how much in M? 100 risk-free, 0 in M. If pi is 0.5, what have you got? 50-50. If pi is 1, what do you have? 0, 100. And if pi is 1.5, what do you have? Negative 50 in the risk-free, so you're borrowing that. And then you've got how much in M? 150. And then we'll do one more. If pi is 2, that means you've got what? You're borrowing 100 and you've got how much in M? 200. Now let's look at what happens if M doubles and compare that with what happened if M halves. And let's first of all do it for pi equals 1. So if M doubles, how much do you end up with? 200. And if M halves, you get 50. Let's compare that with pi equals 2. What happens in that case? If M doubles, your M position does what? It goes to 400, but now you owe 100, so you end up with how much? So you have 400 minus 100, which is 300. And in the low state, what happens? If M halves, you goes from 200 to 100, and then you owe 100, so you get 0. So what's happened to your mean? We think of these as 50-50 chances. The mean here is going to be 125. The mean here is what? 150. So the mean's gone up, just like in our diagram. What's happened to the risk? It's increased. Here your risk is 200 versus 50 for the range. Here it's 300 versus 0 for the range. So this is why when you borrow, your risk goes up. You're borrowing and putting it in the risky asset. Any questions about that?